Hello YouTube, and welcome back. This is the motor driver board that used to belong in the electric car. Whoop! This electric car. Whoop! And as you remember, when I was running this, it blew up and I had to do a little repair here. So I think I need to fix it. Also, the pie seemed to have died, so this bit of pico. And I think this is the same problem that we have before, where the DC-DC converter goes pop. So you need to measure that, and if it is broken, you need to do the mod like I did on this pico here. I'll put a 3.3 volt linear regulator in place. And so yeah, so that's the subject of today's video. So here's a pin out of the pico. So third pin down is ground, and you can tell it because it's got a square pad. Then you've got V-bus, which is directly from the USB, so that should be 5 volts. V-sys, which is the system voltage, which is 5 volts for a diode. Then you've got your 3.3 volt output here of your boost converter. It's gone! Anyway, we can measure them pins on here. So if we go to V-bus, which is from the USB input, we can see that's not right. Oh, come on. Let me push the cables in properly. Oh, it's not working. Right, I've solved the solution. I had the wrong lead plugged in. Anyway, if I go to USB bus, and this is on resistance, we're getting 700 ohms. That sounds about right. If we go to 3.5 volt V-sys, which is the 5 volt after the diode, we're getting a dead short, which is basically not good. So that is the output from the diode is shorting across this thing again. So it's that chip and all that related stuff. It's just poo, isn't it? So what I'm going to do, I'm just going to cut it off like I did with this one. So here's the RS part number and the part number for those playing along at home who want to have a go at actually making a decent, reliable pico. Oh, I shouldn't be so harsh, but I've had so many of these blow up. I mean, seriously, how hard can it be? And with that cooling down, I decided to use a hot air pencil in the end to remove the boost converter chip and the inductor, and that should free the short up. So we'll have a quick measure of that. And if them devices removed, we've got 15k, which is we're measuring the same place on V-sys. So the short is gone. So all we've got to do now is fit the linear regulator. Ooh, it's turned off. And there we go. There's the linear regulator mounted on them pins with the old regulator removed. That should work now. So if anyone at Raspberry Pi wants to give me a job in fixing these, just contact me. I'll be free to pay for lots of money. The next thing I want to do, I want to increase the current rating of these tracks, because I think what was meant to be, this is meant to be wave soldered, and it's meant to be a solder bridge across these. So what I'm going to do, I'm just going to fill these tracks full of solder along the top here, along the bottom. As you can see, it's kind of tracks across, but I think it's meant to be waved. But yeah, I'll just do it manually, and that'll give a bit more current handling capability, or a bit of oof. So hopefully we don't burn another track out. So that's the solder added to the tracks, and that gives it a bit more current handling capabilities. Basically, it makes the tracks effectively bigger, thicker. It's without using thicker gauge wire. So I've done that on the top and the bottom. All the high current tracks are now fat with solder. So at the very least, what will happen is the solder will melt. So, you know, it'd be entertaining, wouldn't it? So yeah, so that's done. Put it back in the car now, and on to the battery next, I think. So I'll wire that back in, and that should hopefully be working. And then the next video is battery time. So I'm going to get that big battery, not that big blue one, but that pink one, and I'm going to make my own pack so it actually fits in. In fact, I've got, there you go, preview, exclusive right here. Anyway, I'm rambling. See you later. Have fun. Goodbye.